In this example, we will find the value of k such that r equals to k multiplied by root 2. You need to understand that k here would be a constant. And also we have been given a few initial conditions which we will have to use. And I have rewritten r equals p squared minus q squared. We will need this in order to find the value of k. First and foremost, you need to understand, or rather you need to identify, p squared minus q squared can be written as p minus q multiplied by p plus q. This is a prime example of difference of two squares. Now that I've rewritten r in these terms, I have to now substitute the values of p and q respectively. So let's start off with the first bracket of p minus q, and that will be root 8 plus 2, that's p, minus q would be root 8 minus 2. That will be the first bracket multiplied by the second bracket, that will be p plus q, and the terms for p would be root 8 plus 2 plus q would be root 8 minus 2. And now we need to carefully simplify the like terms. In the first bracket, you can simplify. Root 8 cancels off with minus root 8, and positive 2 cancels off with negative 2, which means in the first bracket we now have positive 2 and negative multiplied by negative would be positive, so 2 plus 2 would be 4. And multiplied with the second bracket, you need to simplify the terms in your second bracket. Root 8 plus root 8 would be 2 root 8. Now I need to simplify the terms here, and that will be 4 multiplied by 2 would be 8 root 8. We have completed about 80% of the answer. You need to keep an eye as to how r should be represented as. R is equal to k times root 2. In this case, we have 8 root 8, but this root 8 should be converted to root 2. So how do we do that? By now, you might do a straight up calculation. That is, root 8 would be equal to 2 root 2. But for those who do not know, root 8 can be written as 4 multiplied by 2, and using the rules of indices, I can rewrite this as root 4 multiplied by root 2. 4 is a square number and root of 4 would be 2, so we have 2 root 2, which means root 8, I can now substitute root 8 as, instead of writing root 8, I can rewrite it as 2 root 2, which means I have 8 multiplied by 2 root 2. Hence your final answer would be 8 multiplied by 2 is equal to 16, and 16 root 2. Therefore, k is equal to 16. This is your answer. In this question, we will find the values of a and b. On the left-hand side of the given equation is a fraction consisting of numbers only, and on the right-hand side, or RHS, we have the two unknowns combined with the surd. To begin with, I have rewritten the fraction on the LHS. For step number 1, we use a theorem called rationalizing the denominator. What happens here is you have to multiply both your denominator as well as the numerator by another fraction. The terms for this fraction would be a repetition of this denominator. In this case, it will be root 2 and 1. Root 2 and 1. The important point that you need to understand here is If the initial sign is negative, the sign for the second fraction would be the opposite, meaning we have minus here, and in the second fraction it should be plus, and this also should be plus. Do not make the mistake by multiplying only the denominator. That will be wrong. You have to ensure that you multiply both the denominator as well as the numerator, so that you have not changed the question, because this will cancel off to give you this whole thing would be equal to 1. Right, moving on, I have to now expand the brackets. And remember, there is a cut short method to expand conjugate pairs. What are conjugate pairs? These are conjugate pairs. You can see the denominator, that is, in this case, it will be root 2 minus 1 multiplied by root 2 plus 1. The cut short method is simply, this applies for conjugate pairs only. You multiply the first term of the first bracket multiplied by the first term of the second bracket. So root 2 multiplied by root 2 gives you 2. And second term of the first bracket multiplied by the second term of the second bracket, 1 multiplied by 1 will be 1. And always, 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 the sign in between will be minus, because negative multiplied by positive or positive multiplied by negative will always give you negative. For the numerators, we have to expand carefully, and you need to consider each term separately. 6 multiplied by root 2 will give you 6 root 2. 6 multiplied by 1 would be positive 6. Negative root 8 multiplied by root 2 would be negative root 16. If you like, you can straight up write minus 4, no problem. And then lastly, minus root 8 multiplied by plus 1 would be minus root 8. This will be your numerator. Then moving on to the next line, I have to identify the like terms. In this case, I'm going to write this as minus 4. That will be easy for my further calculations. And identify the like terms. We have positive 6 and minus 4. That will give you 2. And we have 6 root 2. That's plus 6 root 2. And I'm going to consider minus root 8 as, up straight, I'm going to consider it as 2 root 2. Root 8 is equal to 2 root 2. I have explained that in the previous example. And for the denominator, 2 minus 1 would be 1. If you like to, you can write it as 1, or else you can simply skip it. And the reason as to why I have rewritten root 8 as 2 root 2 is because now I can simplify 6 root 2 minus 2 root 2 as their like terms. Then the result would be 2 plus 4 root 2. I have now found the values of a and b, and that will be a equals to 2 and b equals to 4. This is the answer. Considering the LHS, I will rewrite the LHS. That will be 1 over 1 plus 1 over root 2. And then I'm going to focus only on the denominator, the terms within the brackets. 1 will be untouched, unharmed. And then the denominator in here, we will simplify the denominator, and I'm going to consider the LCM, that is the lowest common multiple. And this 1 will then change to root 2 plus 1 and the whole term divided by root 2. Please note that the terms inside the brackets are equal. Then moving on, we will consider a theoretical notation A over B over C. What this means is A divided by, I'm going to consider the first line as division sign, and then B over C. That will be this fraction. B over C stays the same. And division changes to multiplication. And if this sign changes, you have to ensure that B over C would now become C over B. This step is called reciprocal, and as you apply the principles of reciprocal, the sign also has to change. So division has changed to multiplication, and the fraction has changed from b over c to c over b. I will apply this concept into this question now. You can understand that 1 would be a, and this term would be b, and root 2 would be c. So which means a over b over c would be equal to a multiplied by c over b. So if I write this in terms of this, I can write it as a multiplied by c, which means 1 multiplied by root 2, 1 multiplied by root 2 divided by b. That will be root 2 plus 1, which means I have root 2 over root 2 plus 1. We should rationalize the denominator. What do I do here? I would first rewrite root 2 over root 2 plus 1. I've just rewritten this. And to rationalize, remember, as taught before, the terms in the denominator do not change. So I'm going to repeat root 2 and 1, root 2 and 1. As I mentioned before, the sign changes. Since the initial sign is positive, the new sign would be negative, and this would be your conjugate pairs. All that you need to do now is to multiply your fractions respectively, considering the denominators first. The cut short method to expand conjugate pairs would be to multiply the first terms. Root 2 multiplied by 2 would be equal to 2. 1 multiplied by 1 is equal to 1. And always, always, always remember the sign does not change, so that will be minus in between. And we have to carefully expand our numerator. Root 2 multiplied by root 2 would be 2, and root 2 multiplied by negative 1 would be minus root 2. 2 minus root 2, that is your numerator, over 1, and your final answer would be 2 minus root 2. We can write this as LHS is equal to RHS. Using this term given here, I'm going to rewrite p squared minus q squared as p minus q multiplied by p plus q. As mentioned before, this is an example of difference of two squares. And this is equal to k surd 4k. We get root 8 plus 4, that will be p, minus, I'm going to use a bracket for q, root 8 minus 4, and the second bracket would be p plus q, that will be root 8 plus 4 plus root 8 minus 4. We can start simplifying the like terms, and that will be root 8 cancels off with negative root 8, plus 4 cancels off with minus 4, which means your first bracket would simplify to 4 plus 4, that will be 8, multiplied by root 8 plus root 8 would be 2 root 8, which means we have 16 root 8. As you have root 8 on the right hand side, we know that root 8 is equal to 2 root 2. If I substitute 2 root 2 instead of root 8, we now have 16 multiplied by, I'm going to use a bracket, 2 root 2, which means I have 32 root 2, which means 32 root 2 would also be equal to k square root 4k. I'm going to consider this part, and I'm going to rewrite this as 32 root 2 equals to k. Instead of writing root 4, I can now write it as 2 multiplied by root k. These are laws of indices. If you follow it, rather learn the rules, then you can understand root 4 becomes 2 and the root of k would remain the same. And as you compare the LHS with the RHS, you can divide both sides by 2, which means I now have 16 root 2 equals k multiplied by root k. And now, as you can see, base of 2 here and 16 can also be written as a base of 2. That will be 2 to the power 4 multiplied by 2 to the power half. Square root of 2 would be 2 to the power of half. And moving on to the right hand side, it will be k to the power of 1 multiplied by k to the power of half. When you have the same base with multiplication in between, you can simply add the powers, which means your left hand side would become 2 to the power of 9 over 2, and your right hand side would become k to the power of 3 over 2. Now, in order to find the value of k, I simply need to get rid of this power of 3 over 2. So you simply need to multiply by the reciprocal of it, and that will be multiplied by 2/3, and onto the left hand side as well, considering the powers, you have to multiply it by 2/3, which means I have now got the answer, because this 2 cancels off with this 2, 3 cancels off with this 3, and k would be equal to 2 to the power of, again here, 2 and 2 would cancels, 9 divided by 3 would be equal to 3. 2 to the power of 3 would be equal to 8. And this is your answer.